All right. All right, welcome back. Let's see. Towards the end of the class, well, hopefully more people will show up. I've invited a couple folks from the IDEA. It's an incubator here at the university. Come by and meet all of you. If any of you has the next Facebook or the next Twitter in mind, or you're inventing the future, they would like to know about it. They have ways to fund server. And they're looking for to get their message out, right, and see if anybody's interested and get some great ideas, right. So that'll be towards the end of the class. I've made available some of the examples that we've been covering for the last week or so, like the page editor that we worked on last Monday. I've made it available here, page editor. So it's one of the examples, and I've broken it up into several sub-examples: code, client-side modules, configuration and service, page list view, and the page details. So I've broken it up. It's quite a bit of source code that we looked at for the last week or so, and I've broken it up this way. I hope it helps. Oops. You'll find that they'll have the first page, the index page as the first resource, so you can look at the source code there. But then down below you have access to the server side app, right? And this is very similar. That we've done several examples of this, right? This is basically the top level module that takes as arguments some of the resources that are being instantiated by the server, and it passes it to us as arguments, right? App, mongoose, and DB. Creates models and services, and basically passes the model to the service so that the service can talk to the model through an HTTP interface. Down here, you can also find the actual service, right? As we've seen, is basically, right, it's a way to interact with the database. For this, it takes as argument mongoose and DB. Right? Mongoose to be able to instantiate the schemas, right? Instantiate the schema, to instantiate the model. So that's what Mongoose is used for, right? So Mongoose is the API, right? That is being passed to us from top level, from the base application is being passed to us. It's being instantiated there. It's used for creating the page schema. So there's the code we looked at on Monday, I believe, right? This is what we looked at Monday. And once you have the schema, right, you can instantiate the page model, which you can then use to interact. Here's the API that the model is exposing, right? The model exposes this high-level API so that you can, up higher, like the service or anywhere else in the application, you can talk to the database at a high level, right, without dealing with the underlying idiosyncrasies of a database, right? Notice that this API allows us, right, this method allows us to really, type whatever we want in here, right? This one is specifically it's using MongoDB, Mongoose API to talk to MongoDB. But in here we could have, it could be just a file system, it could be a network connection, it could be, going out to a web API somewhere. It could be an XML file, it could be a comma separated value file, Could be whatever, right? It could be mock data, the JSON. But that is you know, the good practice of always creating an API, and then, you know, that allows you to decouple these concerns, right? On you know, high level, how do I talk to the data, and then low level, how I actually store that data, right? This is low level to, you know, a particular way of storing data, right? Which is, in this case, Mongoose, right? So yeah, so this is the API that is being passed back to the service. So it allows us to basically the CRUD operation, right? Allows you to add, right? Get all of them, get page by ID, right? We didn't do all of them. We didn't do delete, right? We didn't do update. But I'll show you an example today on where we do create all the CRUD operations. Right? And then it's basically like a proxy, right? It's kind of like, you know, very thin layer that translates, you know, the high level API to low level interactions with the Mongoose. What else? You'll notice that for all of them we used Bird, right? The promise API, and this is promises on the server, right? Again, because the server is talking asynchronously with the database, so it needs to use this API, right? In the client, we do the same thing. We use something very, very similar. It uses almost the same exact interface to service on the client, and that's because the client needs to talk to the server with asynchronously, right? So again, to decouple these asynchronous communications, we use the queue API. What else? Notice that we are overriding the default name of the collection. We are specifically saying we want to store it in this collection. Otherwise, Mongoose would have chosen a default name for the collection. It would have used this name, page models. It would have taken that as the name of the collection. We are overriding that and saying, no, 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 we want this name for the collection in the database. What else is here? I think that's page model. The page service. This is the interaction between the client that is, you know, sending HTTP network connections, right? And here's a server, you know, receiving those connections and translating them into functions. So it's mapping incoming posts, incoming gets, you know, incoming. Why 2 posts? Oh, okay. No, this one is for creating new pages, whereas this is creating new content inside a page, right? So incoming calls. Now remember, this is irrespective of what the client might be, right? The client that we're using is an HTTP, I'm sorry, it's an HTML Angular client, but it doesn't have to, right? It could as well be just another Node.js instance, right? That knows how to send posts and gets. Thing that can send me an HTTP request to talk to me, right? Not necessarily an HTML client. You know, anybody who can send me a request, HTTP request. I'm available. I'm public. Anybody who knows this URL can talk to me. And you know, if you send me data, I can respond, right? For instance, it's receiving this one over here. Add page is receiving not only, it could, you know, it's receiving data, JSON embedded data inside of the body. So this API is a, you know, it's a legitimate web service. You know, it's a pure web service, right? That is completely independent on whoever uses this web service, right? We're using it from an HTML Angular client and rendering it and whatnot, but anybody can create an API, a web API, whatever UI they might want to use, right? It doesn't have to be Angular, right? This web API is completely agnostic, right, on who's using this API, right? And that's how services should be, right? Services should be agnostic on who the clients are, right? It is using a standard, pretty standard RESTful API, right? Post for creating new content, get for retrieving. It's using right, the same URL, the same URL over and over with various gets and posts, right? It's using nested, right? It's using paths, right, to indicate a parent-child relationship between various entities, right? Page and content. There's a one-to-many relationship there, and it's using this, hierarchy of paths to, denote this this hierarchy, right? And they're being mapped to endpoints, right? These are the endpoints. These are the endpoints, and they're being mapped to backend executables, right? That extract the content from HTTP because they know that the protocol is HTTP. This is the interface between the HTTP world, right, and the object world, right, and the binary world that's executing, right. So this is the interface between those two layers, right. I extract data from the incoming HTTP request, and then I pass. So it's the interface between those two worlds, right? The HTTP world and the object world, right? And the model, just like the model is the interface between the object world, right, and the persistence layer, right? Yeah, so there's this is why we call this piece of code we often refer to as the middleware, right? The middle tier, right? The tier that is in between these two worlds and doing the interface between these various layers. That's also we call it multi-tier, right? Because we have many tiers. We have this interface between HTTP and object, and then object and concerns, right? The asynchronous concern, right? The conversion between data types, between the representation on how it's represented, how the data model is represented, the incoming data model, right? And if I have to massage it somehow to persist it. Here, we have very little of that. Notice that we have very little of the conversion between data that is incoming from the HTTP world, right, and the data that we're storing verbatim in Mongo, right? We don't, there's very little mapping that we need to do. It's a very thin layer, right? As opposed to if this were a relational model, right? If this were a relational model, then there would be a lot more conversion, right? A lot more massaging of the data because, we can't have, first of all, you can't have nested objects, object within object. There's, primary keys, foreign key, joining between tables. You don't have inheritance. Well, we don't have inheritance in here either, right? But if we want that too needs to have its own mapping and its own concern. So here the layer between conversion between data model and how it eventually gets stored, it's very thin. Almost no massaging at all. What else? Okay, so that's the source we looked at on Monday. What else is here? Right, so that's for the server side. On the client side, right, you still have the top level index, right, HTML, which loads all the controllers, loads all the services. Notice that here, the problem here, right, that we haven't addressed. Notice that, while we're on this page, notice that we're using a particular template, right? We're using the page list template, right? And obviously, because we're looking at this page, it makes sense that the that the page list controller is loaded, right? We need that JavaScript to be loaded for that particular template to work. Otherwise, Angular would complain, I don't see the controller install, right? Initialize, right? That would make sense. But notice that we're not, notice that if we click on one of these, we navigate to another template. And that template has its own controller as well, yes? But notice that we have this script loaded even before that template gets loaded. You see that? Right? That's somewhat a limitation. Well, not a limitation. I guess it's we're preemptively loading JavaScript that we don't need yet, right? So if you had many templates, right? If you had, I don't know, 20 templates, you could see yourself loading 20 script, right? Preloading them, even though you don't need them. Maybe you won't even navigate to some of these templates. To deal with that, I don't believe we're going to have time for this yet. There are libraries. There are libraries like require, right? We already looked at require on the. We are loading certain modules on demand when we need them, right? Well, we would like something similar on the client side, right? And there's certain libraries out there. Require.js is one of the more prominent ones. Require.js allows you to, not load these things here. So, oh, this template is loading. I need that controller for this template, right? Right, it says load that JavaScript on demand, when I need it, not here like we're doing preemptively. We're not gonna have a chance to play around with that. It would complicate somewhat the code. But just so you know, Require.js is certainly a library. It's a very common library that you find in production environments, that you find in in development environment, in development teams, right? Where you have these. I require certain libraries because, right? And what it does is that it tries to solve this problem, right? That I don't want to have to load 20 JavaScripts if I'm not going to need them, right? I only load them on demand. Nevertheless, here it is. We have the container, we have the page view, header, and then we have a placeholder that loads the templates on demand, right? Okay. Here I have the declaration of the top level application that depends on ng route. We have the config, right? That configures configures the navigation, right? That allows you to navigate to the top level page and then navigate to a particular page, right? What else? And then the details to look at a particular content. Made available each one a particular page, so the template for the listing, right? So here you have the controller and the HTML for it. And so this is the code that we looked at on Tuesday is now available. Notice that here I navigate to a particular details of a particular page, right? And I show you one particular page, the home page, right? And being edited, right? And the object down below. Right, so I'm showing you this particular template, right? This one, page details view, and then the controller that goes along with it. All right. Here's an example I'd like to cover today. I guess people have already played with it. I guess so. Yeah, I guess some of you have already started playing with this example. Please do not put any inappropriate content. Okay. This is one of the websites, and we don't want to put inappropriate content here. That well, I guess it still is a requirement. When we used to host all your projects in the previous version of this course, because all your projects were hosted in in .edu, any content that you would allow people to type in, you had to log in, right? So that it wasn't just open to the entire world. We didn't want people uploading inappropriate images or pasting here inappropriate content. Here, this page is open to the world, right? Anybody can type anything here. Please keep it clean. I forget. Did I implement delete? No, I don't believe I implemented delete. Okay. Anyway, so this example I want to go over with you today is inspired by Excel, right? Everybody knows Excel, yes? And notice that down below in a worksheet you have various sheets, right? And the idea was, well, can we build something that would be friendly on a phone, right, and still give us some kind of a ability to interact with a spreadsheet. So number of sheets, right, and then you can rename those sheets. You can delete the sheet, right, and then once you are in a sheet, then you have this kind of like tabular format, right, where you can type values, little values, right. You can type formulas. You can type some conditional statements there. Now on a phone, perhaps a spreadsheet might be too big. So I was thinking maybe a single column might be more realistic, right? Can we work on a single column? And notice that here you can type literals, right? You can type 1, 2, 3, 1, 2, 3, 4. But then you can type functions, right? You can say, no, I want a function. I want a sum. I want to add a sum. And then notice that it opens up this kind of UI at the bottom where you can what things you want to add. So for when you type a function, you go into this like UI, separate UI, right? That allows you to edit what is it that you want to put in there, right? So I want to play around with something like this. Notice that there's a one-to-many relationship here as well, right? There are many sheets. Each sheet has many cells. Yes. Each cell has different types of content. Right. It could be a little string, right? A little number. Not for me, is it? Right. So I built something that kind of plays around with this idea. Right. So we go there. We can create a sheet. Maybe we call it the budget sheet. Add. Okay, there it is. And then you can navigate to that sheet. And in that sheet, you have to start off with one cell, right? And you can say, you can say income. You add. Then you can say, oh, took a while. This is going back to the server and actually saving this, right? Income, spending, right? And hopefully I'm spending a little less. And then you want to be able to perhaps could say net, right? And in here, you might want to go into some kind of function editor or something that you want to add, or put some kind of a formula here. And these are some of the types of UI or options that I'm thinking of implementing, right? And each one would have different UI, right? Notice that in Excel, right? In Excel, depending on the function, you have a different UI. For some, you can say where to start, right? What cells you want to add, right? This one or that one, or if you say if, then you get a different UI. You see that? If value is equal to, and then value 2, then else. You see that? So each type of operation has a different user interface, right? So here, this is my take on it, right? If you select if, then you get a UI, right? So you can select, which cell, right? Income, right, is greater than than spending, right? And you can select what. Right, I haven't done the sum editor or the average, right? So these would all have different user interfaces. Make sense? Does it make sense? Yeah. So anyway, I started playing around with this, and I was thinking maybe we could take a look at its implementation. Notice that if I go back and I click on budget, right? Notice that the same cells, those are stored in the database. What it's not stored is I haven't stored this yet. I'm not storing any of this. I'm not storing any of this just yet. All right. So that's as far as I got. And I wanted to go over the implementation. So I broke it up into several examples. So let's look at the server side. So instead of looking at it here, I'm going to look in the IDE. Okay, is that okay? I'm going to look at it in the IDE. So I'll have a little more space. All right. So first of all, let's look at the data model. Right, so the data model. Let's see. The data model. I created a schema. Right? And this is my schema. This is my schema. This is my top level schema. My top level schema. And here there's the sheets, right? Each sheet can have a name. That's so I can capture the name of the sheets. These are the names of the sheet on the left-hand side. You see that? That's the name of the sheet. And then I can have cells, right? Each sheet has cells, and cells are arrays. You see that? It's an array of what? Well, it's an array of these objects. Right? Now, this is somewhat what we did yesterday, right? What can I put in a cell? Well, I could put a lot of things in a cell, right? I could put just a little string. I could put a number, right? I could put a formula. I could reference another cell. So there's a lot of things that I could put in a cell, right? And whenever we have something that can be many things, right? The way we normally implement that in an object-oriented world is that we create, we use specialization and generalization, right? We create a subclass, right? And then we have, we create a superclass, a base class, and then we have subclasses for each one of the various. And we talked about this on Monday, and what we usually do when we're going to store this in a database, we flatten that schema, right? Instead of having different objects, we flatten it into a single, right? Into a single object, right? And then we have a denormalized schema where you can have different things, right? You can have a literal, you can have a reference, you can have an if, you can have an arithmetic expression. One of these, not all of them, right? One of these. You can have one of these things. Okay. Right now, I'm only using literal. Right. Right now, I'm only using literal, meaning as you type, these are all stored in literal strings. Right. They're stored right here in literal. I haven't used yet this property, but I wanted to introduce it to you. Right? What I'm introducing today is the ability to declare a schema that it can be much more complex, right? Not just a flat schema, but a schema that is made up of other schemas. Yeah, so for instance, if it's an if statement, if it is an if statement, well, an if statement has quite a few things in there, right? It has, what am I comparing against, right? Value 1, I'm comparing against value 2, right? It has a then clause, it has the else clause, it has the operator greater than or less than or whatever. It's fairly complex. So, I mean, I could have put it in here, right? I could have made an object and put my properties in here, yes? But when you start getting into fairly complex sub-schemas, right? It's often better to declare it separately as its own schema. Okay, so I'm declaring here a schema. It's called the if schema, and I say objects of this type have, operations. It has an input cell 1, input cell 2, a then cell, and an else cell. Right? I'm trying to capture what Excel does. Right? If I have an if, what do I have? I have 2 cell values, your value 1, value 2. I have the operation. Notice that the operation is coming from an enumerated data type. I can only have these operations, right? And then it says, well, if this is true, you want me to evaluate to what, right? So for instance, if I erase this, right, and I say 21, and then driving age, right, and we say 16, then we say, can drive. Here we can put an if statement, right? We can say, we can insert an if statement, and then say, if what? If the age, right, is what? Is greater than, right? It's greater than or equal, then the driving age, then I want to evaluate to true. Right? Otherwise, we evaluate to false. Okay. So if a driving age is this, right? If I say that you're 12, then evaluates to false, right? And so if I say 18, then yes, you can drive. So I want to do something similar, right? So I want to be able to capture all these properties. I want to be able to capture the operation, yes, right? And here I'm saying that the operation can only be one of these, right? Equal, not equal, less than, greater than, right? And I need to tell it, what cell, what are the 2 cells that you're comparing this against what, yes? And then I need to tell it what cell in my value if it's true, or what cell if it's false. And that's the if schema. Notice that it's a nested schema. You see that? Right? It's as if I would have done what? It's as if I would have done this. I would have copied this. We've copied this, right? And I would paste it in here. Yeah. Really to keep track of, right? So instead, it's a good practice, right, to create a sub-schema and then embed it in there. Make sense? All right. What else can you do in Excel? Well, in Excel, you can say, this is equal to this plus that. So you can put in an arithmetic operation, right? You can say this is plus that or whatever, right? So I wanted to be able to do something similar. So it could be, instead of an if statement, it could be an arithmetic statement, right? And it has its own arithmetic schema. You can say, you can tell me the operation, right? What are the arithmetic operations you can do? You can add, subtract, times, division, right? And then the 2 cells that you want to operate on. Make sense? Right? And so again, this is equivalent to having done this, right? Copy this and put it in here. Right? But again, it starts to get fairly hard to keep track of, right? So it's better to have its own schema, right? And then reference it here. Everybody okay? All right? Okay. What else? So this is taking Mongoose notice that the only thing that it's doing here, it's doing the schema. You see that? It's only doing the schema. You see that? It's only doing the schema. I put it in a separate file, sheet.schema. See that? In the previous example that we looked at Monday, the schema and the model were in the same file. Yes, right? And that started to get fairly hard to keep track of, right? Because this is getting fairly long, right? If you see that it's getting split, right? Instead of having the schema and the model inside of the same file, well, it's nice to separate the schema, right? And then have a separate model. Make sense? So in the model, the actual model, right? In the model, we require the sheet schema that we just went over, right? We require the schema, all right, which is in a separate file, right? It's inside of sheet schema server.js. You notice that I am appending server at the end of the file, you know, so that it's understood that this is a server side artifact, right? You know, us as a web developer, we're going back and forth always between the client and the server, the client and the server. Oftentimes we have a file, a JavaScript file, that's called exactly the same thing, and it says, was this server, was this client, what client, what's, you know, it's nice to just put it there so it's understood that it's a server-side artifact. I might have a schema on the client, right, for sheets, right? It's not unheard of. Right? The model, notice that my file is called sheet.model.server, because I might have a model also on the client for a sheet. Yeah, that's not unheard of, right? So anyway, let's see. We instantiate the model out of the schema, and then we create an API to interact with that model we just created. Notice that we have the four operations. Well, 4 out of the 5 operations, right? That we can do with a sheet, the CRUD operators, right? We can create sheets. We can read all the sheet. We can read just one sheet. We can remove a sheet. I'm not sure why I have delete sheet. I think I just renamed one. Create, read all, read one, remove sheet, delete sheet. Why is it twice? Delete sheet. Sheet model, remove, update. Set sheet. I think I must have, this is update sheet. This is updating the sheet. Yeah, update. Why did I call it remove sheet? I remember writing update. I must have done replace update sheet. Replace. I wonder if that's gonna break my client, my service. I have create, yeah, I have everything, right? And update sheet, do I have update sheet? Update sheet uses model update sheet, okay. All right, yes, sorry. All right, yeah, so I do have, we do have the 5 CRUD operations, right? We have all of them. Let's look at these. Let's look at these, right, for a second. These should not be unfamiliar to you. Let's look at create sheet. I believe it's more or less what you would expect, right? Basically takes as argument a sheet object, right? And it basically says, you know, sheet model dot sheet, right? That's something we've done before, right? We've done this for the last week or so. And then it responds with either an error or sheet. The actual sheet object that made it into a database, yes? And notice what we're doing here. We're doing something further, right? If there is an error, we're going to use defer.reject as opposed to defer resolve. In all our other previous examples, we were just saying resolve, right? Resolve blindly. Okay? This is actually calling reject and passing the error along, right? We were just being very very optimistic that we were not going to get any errors. But indeed here we can either reject meaning if we get an error, we're going to say sorry, we can't resolve, we can't fulfill our promise. Okay, what instead you're getting is an error, not an actual object. I'm sorry. Also notice another thing we're doing here is we're not fetching all the sheet. Remember that we were doing that in the previous example, right? When we were creating a new object, immediately what we were doing, we're querying for all the objects, right, and returning that, right, the entire collection. In here, we're making it very, very specific that we are only inserting into a database, right? We're not querying. If you want to retrieve all the sheets, well, you're going to have to do a separate query for all the sheets. Okay, so we separated those two things, right? So it's not in here. Right, so for reading all the sheet, we have a separate read all sheet down here, right? So if we have an incoming read all sheet, right, we run read all sheet down here, right? Where is it? Read all sheet, which is basically a find with no predicates, right? It's basically find, and then we don't have a predicate as the first argument to the find function. And if that's true, then it's going to return all the sheet, right? I guess this should be sheets, right? Again, it's using a deferred reject or resolve if it's successful. There's read one. So read one is right here. Takes as argument the ID of the sheet that you want to read. And it's using Mongoose find by ID, right? And then retrieving that single instance of a sheet, right? And then we're sending it back, and then we have update sheet. So update sheet takes two arguments: the ID of the sheet that we want to update, and then right an object, a sheet object, with the new values, maybe a new name, right? Maybe has different cells, right? Whatever it has, it's going to update that. And notice what I'm doing here. The first thing that I do is, if there is an ID object, a property in the sheet, I remove it. Okay? Because what happens here is that in the previous one, the read all, what's this doing? That's retrieving all the sheet and sending it to the client, right? The client receives it and it renders them all the sheet, yes? Right? So the client, right, Angular, renders with the labels, the names, the cells, whatever, right? And the property ID still is now in the client. That ID property that was on the database, we sent it over, right? We sent all the sheet, right? This is an array of all the sheets. And each sheet has the underscore ID property embedded in there, right? So when Angular sends it back to us for update, for whatever, that ID property is still embedded in those objects. Well, when we do an update, right? What we want to do is if the label change or the name change, those are all legitimate things that can change, yes? But the ID is a reference, right? The ID is a unique identifier, right? It's used as a primary key to uniquely identify each object. Those should not be mocked. Unique identifier that the database uses to find everything, right? To index. So that property should never be mocked around with. So if there's an ID property in the sheet, I'm going to remove it. right? Because I don't want that to be updated. Okay. Now, it's not that I would deliberately change the ID on the client, right? I'm, saving my skin, making sure that if the ID somehow changed, I don't care, I don't want it, right? Throw it away. I don't want that to be updated. So update takes a predicate and says, I want to update the document, right? Whose ID is the ID that I'm passing along, right? And I want to set. Now set, right, is a command, is a Mongoose command that allows you to, set each property in the sheet or in the document, right? So it will allow you to say, no, set the name to this, the label to that, the cells to whatever, each property one by one. But those properties are already in the sheet object, right? There's no need for me to, change one individual. This is replacing the entire. You're replacing it with this entirely new object that is being passed on, and is gonna update each individual property. If it's successful, right, it's gonna return a sheet. Otherwise, it will return an error, and we return the updated sheet. And finally, we have delete. Delete basically uses the underline remove method that exposed by Mongoose, which basically finds the underlying object with that primary key and removes the document from the collection, right? If it's successful, you get a status okay, right? Right, you don't get the object you just removed, right? It's gone. Right? You don't get an object, as opposed to all of these, right? All of these you get objects. See, right here you get the new updated object. Here you get that one object that you were looking for. This one returns in a collection of objects, right? This returns a brand new object that was just created. Yes, but obviously deletes. Right, there is no object. It's gone. Right, it's removed. So what you get back or not. Okay. Does this make sense? Notice that this is completely irrespective on who's using this, what client, Angular, right? Is it a Java? Is it is a Java EE object that is sending client or a C# client that is sending us these requests? Doesn't matter, right? This is the interface between incoming requests and whoever's calling this and interaction with the database. All right, what else did I put in here? All right, so this is the sheet model server. Okay, update cell, wait a minute, create cell. Right, I added, so these are to modify the sheet, right, the top level. So I added API to be able to interact with cells at the individual level, right? So for instance, if I want to create a cell like I did here, right? Right here I have a sheet and I want to be able to create new cells, right? I want to create new cells. I have an API for that. Or if I want to remove a cell, I don't know, did I do that? I forget if I did. Okay, I did remove cells, yes. I like to be able to remove cells, or I want to update, right? For instance, if I want to update this to, whatever, I refresh, it updated, right? It's there. Notice that it's updating as I type. Right? As I type, it's going out to the server saying, hey, this is my new value, my new value, my new value, as I type. Or, if you don't want this to be so chatty, right? Usually we want to avoid chatty services, right? That frequently, you might provide maybe either a check mark saying okay or something, or if you change something, right, then you would get an okay button or something. It depends depends on your particular use cases. But notice that underneath, if you look at the network, as we interact, notice that data is going out to the server, right? See that? And if you click on these, you see that these are all puts. See that? It's a put. Something, right? So we are following with a RESTful API, right? It says, what am I changing? A sheet. Which sheet? I give you the ID of the sheet. And within that sheet, I have a cell, right? And which cell? Cell number 3, right? It's a RESTful, right? Nice, one-to-many relationship. We'll see that in a minute, how that works. Anyway, that makes its way into here, into update cell. Makes its way into update cell. Let's see how we update the cell, right? Basically, what happens here is that, notice I don't have a model for the cell. I don't have a model for the cell. See that? Notice that I only have a model for the sheet. I don't have a model for the cell. The cell is just what? It's just an array, right, of objects. Yes, I don't have a separate model for the cells, right? And we talked about this early on. Whether cells should be its own schema, should it be its own model, right? We talked about this early. If this was a relational database course, we would say, of course, cell would have its own schema, right? It would have its own table, right? And all the cells would live in its own records. You would have each record for the cells. And then you would have like a primary foreign key saying, oh, this cell belongs to the schema, to the sheet, yes? All these cells have a foreign key back to the primary key of whatever sheet they belong to, yes? Right? But here, we don't, right? Each instance of a cell only lives as an embedded object within the sheet, right? It does not live on its own, right? And that's a decision, that's a design decision that I made. Right? I made the decision that cells make no sense to live on its own, right? The life cycle should be that if the sheet doesn't exist, the cells make no sense to stay along, right? Okay, but you might decide differently. So, for instance, if you're an author and you write books, or you're an author and you write articles, right? That too is a one-to-many relationship, right? I am an author. I wrote all these articles, right? Should the articles live under the of articles, right? This could be, author, and then the array could be articles, right? And then inside of this, the schema for the articles could be, the title, the date it was published, right? And then the content of the article, yes? And it would be an array of articles. Now, if we do that, implement it that way, what happens if I delete the author? All the articles are deleted as well, right? Because it's an embedded object, right? Is that okay? Well, maybe you might say, yeah, okay. Well, the author's gone, right? All the articles are gone. Well, it makes no sense, right? So here's where you would design a different schema for the articles, right? And instead have a relationship between them and say, hey, these are all the articles, and all these articles written by that author over there, right? So that if you remove the author, the articles are still live. Right? So those are kind of design decisions that you have to make. Is the we usually refer to these. Are these is it a composition or an aggregation? Right? In database course, we talked about the differences. Right? Is the life cycle of one of the entities dependent on the life cycle of the other entity? Meaning, if I remove one, does the deletion of one cascade to the deletion of the others, right? Or if I remove one of them, does the other one just still keep living, right? And we make those distinctions. So this is a composition. If I remove one, all the children are removed, right? The other one, if you have them separate and you have relations between the two, then it would be an aggregation. So anyway, I decided for this to be a composition, right? And that's a design decision. Anyway, having said that, from our point of view, whoever's using the data model, whoever's using the storage, right, wants to be able to think about the data model at an abstract level. Right? They don't care whether you use composition or aggregation to implement this, right? They don't care about this. What they do care is that there is a one-to-many relationship, right? If I want to create a cell, I'm going to have to tell you in which sheet am I creating the cell, right? If I want to create a cell, I'm going to say, hey, for sheet 1, 2, 3, I want to create a new cell. And here's, if I want to delete a cell, I'm going to have to tell you which sheet I want to delete it from, and then tell you which cell am I deleting. Yes? So that's the high-level data model that I have. Whether it's embedded or not, that's irrelevant, right? So all that, so this is the high-level interface, right? I want to update a cell. Well, tell me which cell. Tell me which sheet. Tell me which cell inside of that sheet, and tell me the new values for that cell. Yes? Right? Now, internally, we know that the cells are embedded in each one of the sheets. Yes? We know that that's how we implemented it. All right, so those are idiosyncrasies about our particular implementation. Yes? So knowing how we implement it, what we're going to do is find the parent sheet, the sheet who has that ID, sheet ID. Find me that sheet first. Now I have the sheet. Now that I have the sheet, I'm going to update the cell. Whose cell? The cell that you tell me. That particular cell. What am I updating for right now? I made it very simple. I'm only updating the literal. That's all I'm updating. Right? The text. The text that appears on the cell. That's all I'm doing, right? So I update it, and then I do my save. I save the sheet back. Notice that it's the entire sheet that is being saved, right? Okay, that makes sense? All right, everybody okay with me? All right. So I just want to make the distinction between the low-level implementation on how we architected the schema, right? And then the higher level, how we are exposing it at a high level, upstream, or how we're exposing this through the API. Yes? The only thing that they need to know is that there's a one-to-many relationship. You need to give us a parent, you need to give us a child, right? And the new values for the child. Yes? Create cell. Again, very high level. You tell me where do you want this new cell to belong to, which sheet does it belong to, and the new value for that cell. Right? The value for that cell. Again, we find the sheet. We find the sheet where the cell should live in. We get and we push a brand new cell into the array of cells. Right? Right now, cell is only coming with the literal. Right? I'm not doing anything else. Only the literal. Right? It's whatever I type here. It's whatever I type. So if I say hello and I add, right? That's a literal, right? The little text that I type in there. Right? Goodbye. What else? Remove cell, same thing. I first find the particular sheet. I have the index of the cell I want to remove. So I splice out from the array of cells that particular cell. And one of them, I only splice out one cell from the array. And then I save the sheet back to the database. Everybody okay? I haven't done yet this portion, right, where you can you can edit this, right, and you can select any number of functions like the if, right, and the if. So each one of these would have a separate user interface, right? If it's a if, you can select where which one of these you want to get the data from, which variable here, which cell. Choose income, it's greater than or equal than, and then then whatever other variable you might have here. And I mean, we could get pretty fancy here, right? Right now, all these variables, right? All these variables are being pulled from the current sheet. Yes. And I mean, Excel is pretty powerful, man. In Excel, you can go across sheet, right? You can say, oh, across, go to the other sheet, and the other sheet has these other variables, right? It's simple. And where else, what the value that you want to evaluate to, right? So I don't have this yet. I don't have this yet. One of my students is going to be working on this, using this as an example. So each one has its own editor. So Max would have its own editor. Date would have its own editor, right? Replace would have its own editor. Length would have its own editor. Right now, I was just playing around with if. And we say done, then the UI goes away. And notice that it highlights. Notice that it highlights the particular field that you're editing. If this were a phone, ideally what would happen is that if I click on this, this would show me a brand new page, right? A brand new page where you would edit, right? You would say done, and then it would go back to to this page, right? I mean, yeah, maybe this would be a tablet version. When you turn it up like that, right? You can stay on the same page without navigating away. But on the phone, you would navigate to a separate page since it's you don't have the space to show two things at the same time. Anyway, for the service, notice I created two different services. I created a service for the sheet. Right? Notice I created a service for the sheet, and then I created a service. I created two different services, even though we know there's only one schema, right? We know there's only one model underneath. Yes? But again, this is exposing the notion that we're treating these as two separate things, with sheet or interacting with cells, right? And instead of putting all the URLs on in the same document, I spread it out. So for instance, in the sheet, right here are the CRUD operations, right? We have being able to create a sheet, read all the sheet, read one sheet, and notice the nice RESTful style, right? Sheet. If you want to create, it's a post. You're going to retrieve all the sheet. That's a get. You want to retrieve one sheet, that's a get, and then the ID of the sheet that you want to get. If you want to put, is again the ID of the sheet that you want to update plus an embedded object, and final delete if you want to remove a sheet. And they're all mapped to the methods underneath: create sheet, real sheet, and basically they are, again, these are just proxies onto the model, right? And the model is who does the actual work. So you see a pattern here, right? You see that there's a pattern, right? In the server, basically you have these services, websites are the interface between HTTP coming in from wherever they come. We don't care, right? Right now they happen to come from Angular, right? But they can come from anywhere, right? And then you have that first tier of the web service, and then the web service using the model to actually interact with the database, right? So this is a nice way to expose your data model, right? Your persistent data model, and expose it to anybody who wants to use this. Okay. For the cell service, I only post, put, and delete. So post. Notice the RESTful API, right? This is the top level parent. Then this is the ID of the parent, and then these are all the children, right? So I'm posting. If I'm deleting, then I do the parent, the ID of the parent, then all the children, then a specific child that I'm deleting. If I'm putting, meaning I am updating, again, the parent entity, the parent ID, then the child that I'm updating, okay? And then mapped to the particular functions that then use the model. And this is the interface, right? This is the interface again that is extracting things from the HTTP request, right? And transferring it over to the model. It says, these are all HTTP. I'm extracting data from the HTTP request parameters, right? The sheet ID, the cell ID, and the embedded JSON object that is embedded in my HTTP body, and then I pass it along to the model's update cell. What else? Create. All right. Okay, enough for the model, for the server. On the client, we have services, mirroring the server services, right? We have two services on the server side. Well, we have two services on the client, right? We have cell service client and then sheet service client. Notice that we append dot client or dot server just so that we understand where's which, right? So for the sheet service, there it is. We have this is what? This is the interface between what? Between the Angular controllers, right, that are interacting with the UI, that world. That's the interface between the incoming UI, those controllers, and the interface, and sending all the HTTP requests to the server. Yes. So this is the service that does this. Again, it exposes. It's almost verbatim, right? What the model does, right? It's almost verbatim the same, right? It has exactly the same method names, right? The same arguments, but the interface is different, right? It's sending the HTTP requests to the server, right? It's posting a sheet, right? It's reading all the sheet, right? Right? It's reading one. Or it's updating one single sheet and providing new values for that sheet, or it's deleting a particular sheet. Yes? Again, this is exposing it to higher level controllers that are using this service. Yes? Okay, so this is being used across controllers. We put it in a service. The reason why we put it in a service is that we want it to be used across many controllers, right? It could be that several controllers might want to use the same API, and so that it's shared amongst all of them. We have also the cell service is basically verbatim the same as the service on the server, right? That it's listening for these incoming. Whereas notice how we are building the URL, right? That's going to go out to the server. We're building the RESTful call, right? We have the sheet, then the particular sheet, and then the cell, and then that particular cell that we want to update, and then the new value for the cell, and add cell and remove cell. Okay. Any questions? This should be pretty easy, right? Everybody still with me? Okay. The controller should be fairly similar to what you've seen before. Okay. Basically, we have in the UI. In the UI, we iterate over the list of. In the UI, the first thing that the controller does is go out to the sheet service and display all the sheets, right? And then sends it over to the UI to be rendered, right? In the UI, it iterates using ngRepeat to iterate, and it displays the sheets. Okay. So this is nothing new. This is nothing new. Create sheet, delete sheet. What I did want to point out is I wanted to show you just this portion, the details. Okay. This is a little bit different. A couple of things here. First of all, notice the expansion. I'd like to show you how to do that. Right, and also like to show you these drop downs. Right, that's a little bit different, and also the fact that as I type, it's sending the data to the server. I'd like to talk about these features. Right? So let me show you this feature first. Right, that as I type, it's sending data to the server. All right, let's look at that. All right, that lives here. In the details view. Right, so this is the details, the sheet details, right? So the controller, what the controller does, when it's initialized, it calls read one, right? Because we have different cells for different sheets, right? Depending on the sheet we click on, we have different cells for different sheets, right? So it notice that it has the sheet and then the ID of that sheet in the URL. You see that? It parses that out from the route params, the sheet ID, and it passes it to a local function called read one sheet, which is, I believe, here, read one sheet. There it is. Uses the sheet ID to call the sheet service. There it is. Call the sheet service, passes the ID, and the sheet comes back, and it sends the sheet to the UI for rendering. Yes? Okay. Okay, so it iterates ng repeat. It iterates over the cells in the sheet, right? So it says repeat over all the cells in the model sheet cells. So remember, cells is an array of cells, right? An array of cells. And as it iterates, right, it displays the content. Well, first of all, it displays in the first column the index 1, 2, 3, 4, 5, 6, 7, right? That's 1, 2, 3. Yes? That's the index. Notice that as I iterate, index is a variable that changes as I iterate, right? 0, 1, 2, 3. And notice that it has a $sign in front of it, right? Just to give you, just to let you know that this is an object, right? That it's a managed object by Angular, right? And Angular is going to update it every time it iterates. And notice that each cell is rendered as an input field. So you notice that each one is rendered as an input field. See that? This is the input field that renders it. Right? And what's the data that's being rendered? It's being rendered cell.literal. Right? That's actually a property inside of each one of the cells, right? That's what we looked in the model, wasn't it? In the schema, right? Each cell, right, is an object that has a literal property. Yes, right. That's coming to the client. So that's what gets rendered. Okay, but the magic happens here. You know, as I type, Angular has an attribute that says ng change, right? Just like there's ng click, right? Ng hover. So there's a lot of event handlers that you can assign. Here saying what we're saying, if the value of this input field changes, I want you to call a certain function. In this case, we're calling model update cell. Okay, and this function is in the controller. If we go to the controller, is declared as a local function. Here it is, update cell. And it calls cell service update cell. See that? Every time we click, every time the value changes, it's calling update cell, which creates what? A put that goes to the server. The server gets the model, right, in the service, and the service uses the model to update the cell in the database, right? So it's pretty expensive. And notice that we are ignoring the response. We're not doing anything with the response. The other is that I've put the table right inside of a row. See that? I put the table inside of a row, inside of a column. See that? Right? And and then I'm saying that, you know, that's how I'm able to have two columns, right? And then as I say done, you know, it checks two, it adds and shows different columns. Anyway, our guests are here. As I mentioned earlier, I invited some folks from the IDEA team. They're a local team that looks for opportunities. If you have a great idea, hence IDEA, you know, they're looking if how can they can help you. They have all sorts of great resources, legal resources, marketing resources. That if you have a great idea, they could help you, you know, incubate the idea here at Northeastern and see if it could grow to something interesting. Let me grab them.
Hello, everyone.
Actually, these are Greg and Annika. Yeah, they're from the IDEA group, right?
Yep.
And that's let's see if you have any new ideas. We'd love to know what you're working on and see how they can help you out with marketing, legal, coaching, and you know, just the whole. I'll let you speak.
Yeah,
I'll let you speak.
we can give
Yes,
sort of
please.
a quick overview, and I don't know if it's helpful to put up some basic slides.
Okay. Yeah, you want to connect here?
Maybe I'll talk a little bit while you look that up.
Sounds good.
So thanks for taking the time to have us by class. My name is Greg Dalman. I work with the University Center for Entrepreneurship. My title
We're entirely student-led, so myself and a management team of about 20 students are responsible for the day-to-day operations. We also have a coaching team. The most successful teams that we work with have people across a lot of different disciplines bringing what they know best to the project. And there's a lot of different resources beyond just IDEA to help entrepreneurship education develop. So the Sherman Center does a lot of different programs for engineering and entrepreneurship. They do speaker series and workshops. The Entrepreneurs Club is a great resource to meet other people interested in entrepreneurship. Scout is out of the College of Arts, Media, and Design, and they are a student-led design studio. So they do branding, web development, packaging, whatever branding needs ventures have. We're here as a component of Northeastern, being an educational institution. We're here to help people potential through learning through the program, acquiring all the skills that it takes to launch a successful company. And the important things to note are that we don't take any equity. There's no fees associated with the program. It's free to anyone who's within the Northeastern community. It's not our resources that's available to alumni, faculty, anyone who's working on something that we can help with. Industry agnostic, we work with a wide variety of industries, from food to health science, software, support it all. And then it's always okay to start again. So starting with something, figuring out it's not going to work, and trying again is more than accepted. In fact, it's commonplace. So that's always an option. And the core of the program is our stage gate process. We take early stage concepts from idea through the business planning process. So we have new venture orientation every other Tuesday, where new ventures can come into the program and get started. From there, they enter the ready stage, where we work a lot on figuring out exact problem they're talking to the people who are experiencing that problem, and wrapping a solution around it that meets the needs of those people they talk to. Doing a little bit of initial market analysis and competitive analysis, understanding what kind of landscape they're getting themselves into. And they take all of that and do an informal pitch to Greg to move into the set stage. The set stage is all about the business model, so figuring out how you take that problem and solution, and how are you going to actually develop it, what's it going to take to get it implemented in the marketplace, what's your revenue model. Lots of questions to ask yourself about how you want to structure the business in this stage. We also have a lot of resources in this stage to help. You'll have a one-on-one coach, and they're experts in ideas process. They're kind of the liaison between the program and the venture, getting them all the resources they need at the right time. We also have in-kind service providers, legal firms, accounting, marketing, PR firms give in-kind support to ventures in our program, so free services in any of those subject areas. We also have a mentor network that we utilize. It was just started up in January, and there's about 50 mentors that so have that deep industry expertise that they can lend to ventures in any given area. And they can also work with Bob Lentz, who's our entrepreneur in residence here on campus. He really loves working with early stage startups. He's founded and been a part of and exited about. He has got just about as much experience as you could ask for. And then the set stage ends with the business model pitch to move into the go stage. Go stage is all about the initial traction and scaling of the business. And in this stage, we have our gap fund. It's $10,000. Full business plan and an articulation of the gap that they're trying to fill. The plans are assessed by our student investment committee, and ventures are put forward to pitch in front of our investment board. We have a budget of about $250,000 for gap funding every year, per year. And we also have an investor network. We make informal relationships and connections to investors that we know through out Boston and around the country. And then there's no formal end to the program, but we're in the go stage trying to get our ventures onto whatever's next. So for a lot of them, it's joining a later stage accelerator, Mass Challenge, Techstars, Y Combinator. We've had ventures go to all three. Takes a lot of preparation and grooming to get to that level, so we're there to help. And then the formal end, I guess, is once a venture has raised over $200,000 in outside funding, they're no longer eligible for our gap fund. But we're always here to help them. Ventures that have been launched from the program for a couple of years now still call us back up and say, how do we like go to market with this? It's a little bit different than the one we had before. So we're always, the people that you meet throughout the program are really, really valuable. And then all of the flashy metrics. In the past 5 years since the program was initially started, 750 concepts, and those are just people who come to the door with something that they want to work on. And of those, 38 have gone through all of the stages and have gone out and raised that $200,000 in outside funding. And collectively, they've raised over $36 million in external funding. And about half of that has been in the past 6 months. So those ventures that started with us about 2 or 3 years ago are now going out and raising their Series A, hiring employees. They have Northeastern co-ops. It's really cool to see. And the staff, about 170 ventures in the program at each of these stages right now. And here's just a few of the ventures that have launched from the program. We have food, Drink Maple is maple water. It's very. We have Amino apps. They do mobile app development for niche communities. They get really good in-app engagement throughout the day. It's for like tweens, so like special interests like manga comics or.
Yeah, so $7 or $8 million in funding based on the fact that they have very deep engagement in the app. So these sort of special interest communities, they find the average user spending, going into the app about 6 times a day and spending about collectively 20 minutes. So really deep engagement there that helped them raise some money. The next one over, Maverick, is a platform for connecting social media influencers to brands. Right, so they identify influencers in social media and help brands like Coca-Cola or what have you connect with these people and then market through them, and they have a really high conversion rate of actual sales. So they track all of that for the big brands, and they've signed up lots and lots of clients, and they're actually finishing a pretty large Series A as we speak. So they're going to be in the high single-digit, double-digit millions in terms of a raise in the near future. Some other technology-based ones, Crystal is a personality profiler that the first product is a Gmail plugin. So it's at the recipient of your Gmail and scrapes the web, does a personality profile on them, and then helps guide you on how to craft the message to that person. So if I'm the kind of person that just wants to get right down to business and you're writing to me and you say, I hope you're doing well, it's going to say, don't write, I hope you're doing well. Just get to the point. Right? And so it's at Crystal. And it's really neat.
It's really good. You can look up your own like assessment.
Yourself, look up your friends.
You can look up everybody. It's really good. It sorts you between 64 personality types and uses that to kind of craft how your communication style works. So we all looked each other up on our team and had a good laugh about it. It's really pretty accurate, and he's doing pretty.
They're getting, it's growing pretty virally. They're getting thousands of signups a day. Yeah. With only a couple of people on staff.
They're the fastest moving venture that we've had. A second time entrepreneur actually came through the program. Yeah, there's a couple others. You can check out our website. But that's the end of our spiel. So if you have any questions, I'm happy to take them. All right.
Really? So in software, for instance, I mean, it's very common that you create a prototype and it works by machine, right? But it needs to scale or it needs to do all that or that. So would IDEA help identify where identify coaches that would help me make it scalable, or that would identify how many people are going to be hitting this? I mean, what kind of coaching would you provide for identifying audiences or identifying what kind of?
Yeah, so in terms of the spreading the word and getting test users and things like that, we do help with. So a lot of the program is driven through customers and getting feedback all along the way. So what we're hoping to do is save time or any kind of wasted resources or effort by building, the kind of the minimal thing, the prototype, the MVP, the first production product, and getting feedback all along the way. And so we try to help you draw that feedback in terms of the development. And when it comes to a piece of software, that's less our specific arena, but there are other folks in the network. So some of the other organizations that sit around IDEA that do help with, the computer science side of things, right? So there's a group on campus called Northeastern.io, NUIO, they call it for short. And they actually, it's students teaching other students specific languages, right? So if you want to learn Python or CSS or something like that, they'll do a course on a specific language that they know really well from working on co-op in it or what have you. So there are outlets there, or just getting, I'm sure those folks would want to mentor and do some kind of, as time went on. But I think,
we also have a relationship with AWS. All our ventures have $10,000 in AWS credit that Amazon sponsors.
Yeah, so we can kind of, what we're trying to do is lower the costs of just getting something out there, right? Help get some guidance on, drawing the feedback that's going to help drive the growth of the product, or just the adoption of the product. And then, as you get into the later stages, it becomes more specific, right? So when you need something with help with something very specific, then we're tapping into our network and saying, who can we help you out with? How can we get you a mentor? That's going to help with, maybe specific architecture questions.
What about things for like copywriting or patents and things like that? Do you provide support for that?
Yep. So on my staff, there's a co-op out of the law school, and it's her full-time job to consult with ventures on legal information, and then she can connect ventures with our in-kind service providers. So we've got about 10 firms here that she can connect you with for the actual filing of the patents and incorporating the business.
So once you get organized, talking to the legal officer that's part of IDEA, there's an IP collab on campus, which is a group of students overseen by one of the senior law professors that actually does, is this patentable? How do we protect this copyright? Or what have you, right? So they'll do IP work on campus. We also have, as I mentioned, 10 firms that are off campus that do a certain amount of in-kind service. Trying to form the entity of the business, if you're trying to, or you're trying to, discover if something can be protected legally, we'll get you sort of the first piece of that project for free. And then, once you have all the information, we'll kind of move on from there and have your own relationships with firms around town like Goodwin Procter or Wilmer Hale. These are kind of well known for working with young companies, and they're very happy to be a part of our program.
Anything else?
So there's no fees associated with all these services?
No, so we're not taking any equity. You don't have to pay any money. Any of the work that you do. All right, so as long as you're not doing something that's using substantial university resources, if it's your own project, right, you own everything about it, right? So there's that's one of the differences between this program and some other accelerators, right? They're going to ask for a single-digit percentage of equity. Maybe they're giving you some money. Anything other than that, somebody on the founding team be affiliated with Northeastern, right? And this is supported by donations from alum that want to support an entrepreneurial, activity at Northeastern. And so the whole model is the people who founded TableList and Maverick and Amino, people a piece. Now they've raised $5, $6, $8 million, and have a business that's off and running. The hope is that, and I know they're all thinking this, that they'll be, kind of donating back to that pool to help the next people. So that's really how it works. But there's no obligation. Any other questions?
One last little plug. So next Thursday is our annual venture showcase, Nexpo. And so we have about 40 ventures that are going to be presenting there, sharing what they're working on, working through the process. So I'll leave a couple of these cards. If you're interested in attending, definitely do so. It's 6 6:30 in Cabot next Thursday.
Awesome.
So that ain't- All right, thank you guys.
Thank you.
Thanks a lot.
Yeah,
go ahead.
Thank you guys for your email address.
Yeah, oops, I accidentally deleted that last slide. You can email me at idea@neu.edu. Yeah, and I answer that email every day.
Thank you.
Thank